And all right, good to go. So for exercise 4, as you can imagine, we're doing stairs, ramps, and rails. And I have attached our actual assignment sheet to Miro. So just to kind of cover real quick, just because, I guess we could read this for ourselves. It does go over the instructions of at least the steps that we're using, such as a 6 inches by 12 inch tread. The ratio that we need for ramps, which is a 1 to 12, which I'll obviously cover in this tutorial. But if we were to go over the instructions, make sure abstraction is saved. That's clear. Kind of save it off, put it to the side, right? Because next week we'll actually put the stairs and the abstractions together, right? So don't do that yet. Don't get ahead of yourself, because there are some specific instructions for that, but we'll do that next week. Start by using your top, front, and side views to create the necessary profiles. We'll go over that. Complete a run of stairs as needed. Copy and continue until the process has reached, that should actually say 50. I can't remember. Sometimes I change that height, like sometimes it's 60, sometimes 50. I would go to the one of the assignment that we actually used, and I think it's 30 by 30 by 50 if I'm correct. Okay, so again, scratch that out, say 50. Rails can be made in a one pipe and use profile curve to have handrails at 36 inches above finish. So of course we'll explain all these different things, but lastly, the one that may trip people up the most is the plan oblique. And if you guys remember from graphics 1 and graphics 2, a plan oblique is a 90-degree drawing, right? Essentially the floor plan is the axonometric drawing view. And to be fair, there's not really a pre-setting for that in Rhino, so I have made a Grasshopper algorithm, which I'll of course share with you, and you don't even have to do the work. You just need to download it. But wanted to show you the incredible projections that we can do in Rhino, of course. So I'll end with that for today. As you can imagine, it looks somewhat like this. I just didn't have actually a stair graphic, so I often just use this one. But as you can see, we're following along, and yes, exercise 3 was supposed to be to today, but it has moved till tomorrow. And as you can see, this one I am giving a week for. It can take us some time, and let's face it, it's also to help out with a little bit of exercise 3. So if there's some models that you still want to change or still, fix, it gives us time to basically, finish exercise 3 and exercise 4 by next week. As you guys could imagine, by week 5 we do not have class on Monday, thank goodness, in observing 4th of July. But of course that's when we'll starting to merge these things, make them either out of the laser cutter or the 3D printer. So we'll get there when we get there. But let's go ahead and get started and make some stairs, right? So it does say use the profile method, and I do want to express what that means. So as you can see, I have my 30 by 30 right here. I'm going to go ahead and copy it and make it 50 feet. And very often I do this just kind of in practice to kind of give myself a ballpark of where I'm supposed to make these stairs. In fact, I'll even go a step further and sometimes even like just make this wireframe box. Now this isn't like a solid box, and it really is just there for reference. I don't need you to necessarily show it in your final diagram, but it's kind of a nice reference. It's something that I would often do on the drafting table when I made stairs. I would literally do every grid line. So a lot of those practices, again, it's just kind of advice. You don't necessarily have to do this part if you know where 50 feet is. But another tool that I forgot to mention maybe in the previous videos is that we have the inherent ability to dimension just about anything. So if you type in DIM, enter, and you select 2 points, and basically move that out. Now in the perspective view, it's only ever going to go to your bottom Z plane, so you'd actually have to select a different view. But we can get 50 feet, right? And I can't tell you how awesome sometimes this is, because what's even greater is if I move it, and I believe I actually have to move all of these. But essentially you should be able to move it and get a different dimension as well. However, it doesn't seem like it's actually connected. So let me just show you what I mean. Yeah, there we go. So they're live, right? I mean, they actually give a nice representation. I'll get a history warning, but it's okay. But again, if those things are attached when you move them, it's kind of nice to, have some parametric architecture involved. But let's go ahead and get started. And to be fair, there are a lot of different ways to make stairs, but I will go over, I'll try to at least go over 3 of them. More often than none, students' first reaction to making stairs is simply like making a box, simply like this, and making stairs, and I see this all the time, every semester. This is not the right way to make stairs, right? I don't know who needs to hear it, but please do not make stairs this way. And the reason is because, well, it's kind of a false structure. I mean, let's face it, that would like break apart instantly. And there's also like stairs on the other side, and it can get pretty confusing actually when you're looking at certain drawings, or if you got the hidden lines involved, like holy crap, like, I mean, you're gonna get a lot of lines that are unnecessary, and just, you're gonna give yourself less time, to of course fix these drawings. So public service announcement, let's not make stairs that way. The best way to make stairs is actually to draw them, right? Make the profile. And the reason I say that is because often in architecture, we don't always need a three-dimensional view. Sometimes we need an elevational view. So it makes a lot of sense to always draw it in 2D. You guys may have noticed with my team A, I told them that they just need to trace that site plan, right? At the end of the day, we need that 2D in order to make the 3D, but we may need to go back to 2D to express to our professors and things like this. Can't tell you how many times I've had a professor, especially at SAC, that goes, I don't want a 3D site analysis, I want a 2D one. Whereas at Texas Tech, they prefer three-dimensional site analysis. In the profession, they prefer 2D or sometimes 3D, right? Depending on the client or the clientele even. So, it makes a stronger student to, of course, know both. But the first stair that I would go over is simply drawing a profile. So in our case, quite literally drawing that profile 6 inches. Enter. I don't know if that's 6 inches. That's not 6 inches. Polyline. 6 inches. Holding shift won't help me here because I'm in the parallel view, but it will help me here. And 12 inches there. Now I could draw every single step, I really could. Or I could work a little smarter, take this exact step that I have, the exact same point, and basically copy that over and over again. So now I've got 4 stairs, 5 stairs, 6, 7, 8, 9, and 10. We'll do 10 stairs, right? However, if you know anything about stairs, you know that you don't want to end it on a tread, you want to end it on a riser. So I may need to add one more line in there, right, of 6 inches. One thing I also forgot to mention is that we can take separate lines, and as long as they're touching perfectly, and what I mean by that is, you'll see that the same point actually reenacts, and you can zoom in and zoom in and zoom in and zoom in, and it's always going to be attached. You can take all of those lines, you can type in join, enter, and it'll actually turn it into one component, which is really nice. If you group something, it doesn't quite do that, right? It does like keep them all in one spot, but it doesn't really put them together, right? So be very careful about how we use group. And the reason I say that is because, well, sometimes students, they accidentally use group for join, right? When you can actually join objects. Keep in mind, join only works on 2-dimensional objects. If I wanted to put 2 3-dimensional objects together, what would I use? Anybody know? Who's paying attention? Boolean union, that's correct. Right? So, in my case, you may have guessed it, I need to get the underbelly, right? The other side, right? And actually one of the best examples of stairs, especially at San Antonio College, is just to go into the fire stair. Take a look at it and go, hey, that's about 8 inches or 6 inches, or, oh, I noticed they have a little tongue groove. I could really get fancy with the spices here. For instance, let's make one off to the other side. We'll get my polyline again, and I could get the little toe kick. You guys know what I'm talking about? That little toe kick where your foot can kind of go in. So, I mean, you could get really fancy with the stair profile. I mean, another profile we could do that's a little bit more realistic is like this one. You've probably seen it before, right? Something that literally even has almost like a piece of wood almost like on the concrete. So I mean, we could really get fancy with the spices. And one thing I would say is don't be afraid to find a stair and go, hey, I want to model this, right? I really like that floating stair look, and I'll try to go over a floating stair today. Now what's required is just this one, right? You don't have to get fancy, and I would say if you do get fancy, make sure you continue being fancy, right? Don't have like this kind of stair with this kind of stair, and it just starts to look a little disorganized. So Anyway, just wanted to offer obviously some options there. But we need to draw the rest, and so often what I do is I maintain that angle. So I'll take my bottom point and my other bottom point, and I'll essentially just offset that. In my case, I'm going to assume that this is concrete, so I'm going to go with 6 inches and basically offset that out. That way I can maintain that angle, and it starts to look more or less like one of those 2x4s that you get at Home Depot when you're trying to make stairs. Anybody make a deck at home? Nobody? They sell this part, by the way, right? That's just like, you know, stair stringers is what is essentially this is called. But let's finish it. Let's draw the rest of it. In my case, I'm going to draw the landing. And since I have a 4-foot width of my stairs, I need a 4-foot landing minimum. Right now, I could go bigger. I could, you know, do all that. But let's at least start strong and complete this profile. Sweet. And I'll go ahead and join that all together. And really the last tool that I can't express enough is probably one of my favorite tools is the ability to close something without knowing where it's open. So for instance, I mean, we know where this one's open. It's that little bottom piece right here, right? So you'll notice if I move this up, it's like, ah, man, I'm missing a piece, right? Now, don't get me wrong, I could just draw a line. That one's pretty simple. I can see it, right? But sometimes I get these weird things where it's like this, and you may too, right? Where it's like super close. Sorry. Super close. And from back here, it looks like it's closed. And when I extrude it, it's not closed, and I can't cap it, and I can't close it, and I can't figure out why. And sometimes it's because there's this microscopic moment that I don't know where it's actually closed. So one thing that we can do when you have a joined item is you can close curve. And it'll automatically close it for you in the spot that it's open. Again, you may just need to refer back to this one or write that one down because it's easy to forget that one. In our case, once I have my profile, I'll extrude that profile, go all the way across to 4 feet, and voila, we got a stair, right, to say the very least. Another thing that we can do with that is, well, that wonderful sweep tool. I can't tell you how many times I help students go, well, sir, I really like the stairs, but I want to do something different with my stairs. Maybe something like this. You know, maybe I want my stairs to essentially follow this path, if you will. So I would do a sweep. Sweep 1, it's going to ask for my rail, profile, enter. Direction doesn't really matter in this case. But as you can see, I can make a lot more. So close sweep. Oh, it won't let me close sweep. And it may be doing that just because this is slightly on that. So let's move that a little bit. Boop. Let's try again. Rail. Piece. Maybe change our direction a little bit. Boop. Get it off. Usually you don't want your directions like on points. Rebuild across. No. Do not rebuild. Rebuild with sections. Let's do a simpler geometry maybe. Let's just bend the corner. Rail, profile, and direction. Sweet. So a little bit simpler. I think it didn't work because I was like bending in and back on itself, and there wasn't enough length to do so. But that's okay, because we could still do something like this, which, I don't know, maybe you don't need necessarily for this project, but I can't tell you how many times we build near the river, and I've always kind of wanted these stairs to go near the river. And, you know, sometimes the river isn't always straight either. So another one that we could use is this kind of curvilinear tool. And let me get to another view. Let's look at it from the top, say something like this. Maybe I'm going towards the river like that. Sweet. Now, this obviously doesn't exactly pertain to this project, but, you know, clearly useful in studio and design. So, can't tell you how long that would actually take me, and I did. I would sit there and draw each one, and I would extrude each step, and I'd put them together as a student because nobody told me that I could do a sweep tool on my stairs. I didn't know it was allowed, right? But of course from here we still have an open object, especially if you didn't check the little box that said solid. So if I type in cap, of course I can turn that into a solid object. I could start to wire cut it now. I could really make it my own. So like, I don't know, say I had a tree in there. Not to get too fancy with the spices today during tutorial, but my goodness. You know, let's get a circle in there. Put it right over it. I don't know, that's a little too big. Tree size. There we go. Where'd it go? Oh, there it is. So for instance, if I needed to cut something out of it, again, I can't express this enough how cool this object is. In my case, it's going in like a random direction, so let's reset that to Z. There we go. Awesome. Take that piece. Got a spot for a tree. See what I mean? So again, modeling something like that from like scratch is just absolutely pulling teeth. So anyway, back to the assignment. Just wanted to show that, of course, there's some options like that. But in our case, let's remain and start extruding and building some stairs. So I'll extrude curve, go to the other side. We'll call it a day. Now, in my case, I may want to get a ramp in there, and obviously this tutorial isn't for like the design portion. Obviously, I'm just going over some of the tools that we can use. But as you guys may remember, we can also hold Shift and Command and select any face as well. So there are a couple of options there. So say I wanted to select this face. If I hold Shift, I can actually move it and create no line. If I hold Shift and Command or Control on Windows, I can actually make a new line, which is kind of nice because, well, if I move this now, I can make a ramp, right? Now, the next thing that I need is to make sure that that's 1 to 12, right? So I wouldn't just want to move that, you know, sort of haphazardly. So another thing that we can do is move face, right? And as you can see, there's all kinds of moves. There's move, move curve, move edge, move face, move hole. I don't even know what move hole does. I don't even want to know. But in our case, move face, right? I can move this a certain distance. So if I need it to be 1 to 12, I'd move it 12 feet and go up 1 foot, right? So if I go 12 inches, I'd go up 1 inch. That would still maintain that 1 to 12 ratio. In my case, let's get specific, right? And move this a certain distance. In my case, I don't know, I kind of want another landing there of 4 feet, so I might want to build that first and say, I don't know, rectangle, regular building pad. We'll go with a thickness of, well, you know, I don't actually know what that thickness is, so maybe let's measure it with DIM and go, okay, 0.95. And if you don't like decimals, you can always double click these things and actually change the units, or it's in feet decimal, so we'll not choose decimal. Let's change that. I believe it's length units, yeah, feet. And let's change it to feet and inches. Nice. So 11 1/4, sweet. So now we know the exact distance. That way, you know, things line up. And like I said, this one's gonna be a little bit more practical, right? So we'll take that piece, extrude. We'll go 11.25 inches and go from there. We can also basically just put it on there now, right? Oh, not that one. Actual solid object. Let's just make a copy just in case I mess up. And put that there. Now from here, you're like, okay, well, still, I don't know the distance, right? But I can move that across. Woo! There we go. As you can see, especially in this assignment, I have to use kind of all 4 views. There's only so much you can do in one view before you accidentally draw in one view and you think it looks like there, but the point's like way over here, right? Has that happened to anybody yet? And it can be disorienting. So again, there's a reason why we start off with 4 viewports, and there's a reason why we do that on the drafting table. You guys are pretty used to constantly looking at the front, the top, the side view in order to project a new axonometric view. But from here, let's go ahead and make that ramp. I need to know the distance, so we'll take that distance. I could just type in length, right? And of course it'll give me at that little location down here of 8 feet. All right, so I can do the calculation. That's about 2/3. 2/3 of a foot is 9 inches. Everybody with me there? Anyway, so this essentially needs to go up 9 inches. So we'll move it. We'll go to our other view, and we'll go up 9 inches. Sweet. So, I mean, don't get me wrong, I could build another profile and I could just stretch it, or I could simply take this face and attach it to this one. All right, so I'll take that one. I do want to maintain this view, so I'll take that one. I'll hold Shift and Command and essentially just take it over here. All right, now I can still actually move this one. Right, so if I needed to move it based on, like, say, move face again, I could take that same point and basically attach it to that point I need. Not too shabby. I could also just fake it till I make it. Let's face it, it's just for an exercise. I'm not going to go in there and measure it. But if you're in graphics 2 or 3, they might, right? Especially Balderas, myself, Bosoft, Kernodle, especially if it's in graphics, right? In Studio, we're not so harsh about those things, but again, I don't want to leave you in the dust. So there is a practical way of doing these things, and accurately and perfectly. But from there, I mean, I don't have to do that all over again. I could just take this piece and copy it. I could take the entire thing, take one right here, and rotate it. Boop. As you can see. However, I've got my mistake. I may need to actually make another triangle here, right? Or maybe try a different extrusion. Maybe I don't want necessarily that ramp again. So again, this is why we draw things in 2D. So I can take that 2D again, I can copy it. Boop. And of course rotate that as well. You'll notice with the rotate tool, I usually hold Shift to keep like a 90-degree angle. That way, when I move it, it's a little bit more coherent. But as you can see, I can actually explode this and redraw it. So if I do need that little angle, or if I want to extend, and another tool I can use is fillet. Right, so if I fillet something with a radius of 0, that looks like a 0. Man, my eyesight is pretty bad. But I can take this piece and that piece and have them connect to each other. Now, if I put a radius of 5, it's going to actually make a little radius at the end, so just be aware of that. It's just kind of the way that I use the tool, just because it's kind of nice. In my case, it doesn't look exactly straight, so let's try that again. Fillet. Looks like it actually like transferred it a little bit. That's kind of weird. Let's go with line, line, yeah. That one. There we go, much straighter. And when you use the fillet tool, these actually do turn into a point, so there shouldn't be any opening there. But once I was done, we'll turn it back into a joined object. So I'll take all of that, join it, and extrude. And if I didn't talk so much, well, I could probably complete this a lot faster, but voila. Right, starting to look like some more reputable stairs that at least match. Right, not too shabby. All right, let's continue. So, I mean, another thing you can do is kind of the SketchUp method, right? Where essentially you're just taking these points, moving them. And we get really fancy. Right? We could basically just use our gumball tool, especially if we were just kind of, I don't know, showing our studio professor maybe a certain design or something. Oh, let's try that again. We'll take some finesse, right? But if I wanted to have like a separate observation deck, could. Get fancy. From there, I can continue the stairs, right? And maybe I want to, I don't know, continue the stairs out here. So we'll do that. In my case, select that face, and I can either do move face or move tool. Like, there's definitely a couple options there. In my case, I do want it to hit that edge, so I'm going to do move face. Oop. Keep in mind, you don't have to select the face to enact the program either. So like move face, it's going to ask you, hey, which face? This one, enter, right? That way you can take a certain specific O-snap point and move it. But as you can see, it's going to take everything with it. So maybe that's not the best method. In my case, fake it till we make it. No big deal. Now I can move that face back and be okay. For the sake of the tutorial, let's just go. Close enough. But I already made a stair, so might as well take that one. Or, again, maybe I have 2 separate pieces now. I've got a couple pieces. If it's not working, it's not working. But I did make a new profile, so I don't necessarily have to do all that over again. I'm going to take a familiar point, right, that previous stair point, put it on one that I know, take the whole thing and rotate it. Boop. And extrude again. In my case, if I know my dimension, I could say 4 feet, enter, and we're good to go. Right? We can continue over and over and over again. You can even take this entire piece, copy. Don't necessarily have to do like a profile every single time. Again, I'm not trying to confuse, but what I am trying to say is there's definitely more than one way to make stairs. However, I really wish somebody would have showed me this way, because I built some really bad habits making some stairs, let me tell you. But starting to look pretty good, at least for a regular precast concrete stair. Now, if I wanted, say, a floating stair, obviously I would just have to change my profile a little bit. So for instance, let's kind of make it off to the side just to make that a little easier to see. But I'd want to build my stringer, and if you know anything about a stringer, it's usually kind of thick. You've seen it definitely in a residential situation where you have kind of floating stairs and you can kind of see through the stairs. So you could do it all at once, really. In my case, I'm going to take this piece, kind of want to find it better. I want to see it in my view. So let's move it off to the side. There we go. I guess we no longer need that dimension. But I'd want to build it, right? I'd want to make my rectangles, if you will, right? My little wooden pieces that are essentially going to float. And I don't want to do that necessarily over and over again. So, boop, boop. Make a lot of boop noises. I do apologize. But yeah. Now we can get that piece. We can even take these points only and move them over. Voila. And now it's almost like we got every single piece that we need, so now we just extrude it. All right, we'll take the entire thing, extrude. We'll go 4 feet. Oh, we don't need the stringer to be 4 feet, so let's get that one extrude, I don't know, 6 inches. That's a pretty big beam, but we'll take that one, and we'll take the leftover. We'll hold shift so that we don't take this one or that one. We'll extrude again, and we'll go with like 4 feet. We'll take that stringer. It's starting to look like floating stairs, right? And we just need to put that guy in the middle, which of course we could put to the midpoint and have some pretty cool floating stairs. Making some sense, right? But essentially just using the exact same methodology, right? Make a profile, draw that profile, make sure it's a closed profile, and extrude, right? So, or sweep it, or what have you. But we'll continue with our easiest one, which is just kind of like a precast concrete. And let's go all the way to the top. And so for the sake of tutorial, I'm just going to kind of copy and paste. You don't necessarily have to do it this way. You can totally get fancy with the spices on this one. In fact, I'll show a video after this tutorial. Have fun with it, right, to say the very least. So again, just holding shift and command or shift and control. Holding shift and control again, and when I move that with gumball, we get some extra stuff. But I don't know, I don't like boring stairs, so let's keep going. Copy, let's get to the top. Take a known point, be careful, this is what I mean by a known point, one that is like obviously all connected. An unknown point is like that. Like, dude, how are you going to use that, right? I mean, you could, but you're just making your life a little bit more difficult. But copy from a known point, one that I know that I'm going to use again. So in my case, here's another known point. Boom. Rotate it. I'm going to hold shift for that 90 degrees, hold shift, and move it across. I know some of us who have maybe even taken graphics too already are like, God dang it, man. I already did this, by hand. What do you mean it could be way easier? Well, it can be, right? Let's get another one. I mean, why not? Yeah, that's a known point. However, sometimes I have like the same direction, so I don't necessarily need to rotate. So I was just kind of looking out for that. Again, known point, and known point. Nice. Rotate. 90 degrees. 90 degrees again. I may need another landing. Good thing I think I have one down here. Ooh, nice. Got one right here too. Copy. Because, I mean, I'm not trying to waste time. I mean, obviously in studio sometimes, you know, we got to think about these things a little harder. But wait a minute. Make sure it's, of course, in the same plane. There we go. Another thing that's kind of nice is as soon as you Boolean union something, it does remove some of these lines. So Boolean union, I basically just put those two together. Be very careful about that, because now I can't like really copy this without, you know, getting that level again. But in my case, I may want to use it, so I'm going to take that, copy. Again, this is all for the sake of tutorial. And no, they don't have to be like truly structural. As you notice, like nothing's really holding this up. That's kind of the point, because we're going to put our abstract with it, right? Just not yet. But in my case, let's get another one in there. That's kind of a known point. I just have to move it across 5 feet or 4 feet. Sweet. But now I can't just like take that same one. I kind of have to do the same thing again. We'll take it, copy it. In my case, I'm going to choose the right direction here. So, boop. And sweet. Almost to the top. We're almost there, guys. Looks like I could probably copy that over and over again, though. Right? So let's take that one, Boolean union. Put those together. But eventually, as you can imagine, we're almost like making a fire stair. And copy that one. You're going to have some repeating elements, if you want that. Now, if you want an absolute crazy stair, you want to go MC Escher on us, that's totally fine. Man, we're so close. Let's get one more. Oh, yeah, let's maybe get that one. Copy. Known point. Looks pretty known. And again, intersection is like your best friend, especially when you're doing stuff like this. Oh no, I don't have a known point. What do I do? Well, that's kind of a known point, and then I know that I have to go up 6 inches, so I could do that. Move. We'll go to a different view on that one. I'll click anywhere and go up 6 inches. I'll hold shift to make sure it's straight. And voila. We've made it to the 50-foot mark. Now we're about 2 inches over, and that's not a big deal, right? In fact, we could even probably squish it a little bit. In my case, I may either have just kind of an error, and, oh, I know what it is. I put a tiny little ramp in. That's, of course, why it's up 3 inches, right? I only went up 9 inches instead of that full 12. So I would probably have to add another ramp to either go down those 3 inches or, you know, on the way, maybe I just actually stick to that 1 to 12. But as you can see, I still need another little ramp. But even from here, you could get fancy with the spices, right? Maybe you have another observation deck. Because what's also nice about this is immediately, as you guys know, we can get the rendered view, and we can also get the shade and shadow, right? Which is like an entire assignment in some cases, right? Done. Right? I can't tell you how awesome this program is, right? Especially compared to the drafting table. But instantly calculated. In fact, I even offer this a little bit to my Graphics 2 students as a way not to necessarily cheat, but who's got the time to calculate every stair shadow? Sometimes we don't have 16 weeks for a project. We have 2 for a client. So again, there's a reason why we use this technology. But for the sake of the assignment, I completed the run of stairs as needed. I'm going to move on to step 4 and copy and continue the process. Well, we actually did that. Now let's get some rails and call it a day. No, we want to go over Grasshopper too. So for the assignment, that's reaching the top. Let's get rid of anything we don't need anymore, I guess. Don't really need that bounding box anymore, so I'm just going to hide it. Boop. Sweet. All right, we're getting somewhere. And there's those floating stairs that we don't necessarily need anymore. In my case, I could put it all together, and that might, you know, ease the brain a little bit, but be careful, because if I do want to change it, it makes it a lot harder. I can't just explode this. It's going to get into a lot of different pieces, but for the sake of looks today, let's try Boolean union. I kind of want to see it as a completed object. Not too bad. And there is something to be said about Boolean union. We do need a Boolean union object to eventually 3D print. So that will come in handy, of course, in the future. But let's get some rails on this guy. I mean, people are just gonna fall right off. I'd be absolutely terrified to be on these right now. So the best way to do some rails is to actually just draw the polyline. In my case, I'm gonna start down here and essentially trace my stairs now, right? So as you can see, I've got all these wonderful points. I definitely want a rail that kind of goes up like the ramp does. I want it to go flat again when it gets to the landing. And I might need that little bump up, just like you see in commercial stairs all the time. They're actually particularly for those that are visually impaired, right? So that they know when they're actually stopping and starting a new stair. You may have noticed that, right? You see the stair kind of like loop off. That is not just because somebody was lazy. That's actually to tell somebody, right, that, hey, the stairs are ending. You're about to fall off. Those kinds of things. But, yep, I do have to waste a little bit of time for the tutorial today and basically just trace these. Obviously, if you had me for D3 or D4, we also do this one too. So, might just be a nice refresher. But again, just tracing my my extended points of my object, and yeah, in my case, I'm going to go literally all the way up one side and go down all the way the other. So bear with me on the timing of this one. We'll go up there, we'll go up again, we'll go up there, we'll go up again, we'll go up there. There's a lot of stairs. But luckily, I'm not having to draft all this, so that's kind of nice. As you can see, I can get all the way up to the stair. I almost need that point, but okay. Let's just go weird on this one. There we go. It'll be a funky rail. That's okay. And back down, as you can see. Now this is where you do want to be very careful. You can accidentally click on a point that you didn't mean to, and yes, you will have to start over in a sense. But not really, because you could totally just stop and join two lines that, are maybe correct. Hopefully that made sense. But yes, we do essentially have to go all the way back down. I mean, if we want the full effect. Well, let's face it, we want the full effect. A little tedious though, as you can see, moving around. And I don't know. I think the easiest view to probably do this in is perspective, but I've seen others, do it the way that they want. That's cool too. Whatever floats your boat. Trace, trace. All the way back down. Boop. It's looking pretty good, actually. I do say so myself. Right. This will be the little Titanic, spot where couples can essentially just go and do the Titanic shot. I swear, nobody gets my jokes, man. All right. Now that we're done, enter, and we have this continuous line, right? And that will definitely come in handy because now I can take the entire thing, and I do need it to be, well, 36 inches above finish. So, especially in the United States, we definitely need 36 inches. Often, especially even if it's outside like New York, you need 42 inches, especially on buildings because, I don't know, I guess people jumping off buildings. You may have noticed, like, especially really like the Empire State Building, they have like a whole cage now. I guess it's a thing, but this is also familiar in Japan as well. Anyway, random facts of the day. We'll go ahead and move it 36 inches. We'll make sure that it's straight. You don't want to go this way or that way. Hold shift, click. Kind of get where this is going, right? I could either sweep, right? A really awesome, like say Louis Kahn is notably famous for certain handrails that quite literally go around the hand. You can make like a really interesting profile. For the sake of tutorial today, I'll just pipe it. And we'll do a very specific dimension. Usually handrails are about 2 inches in diameter. So for our radius, we'll go with 1 inch. and the in radius 1 inch as well. So when I hit enter, we should be okay there. Yeah. And now we have handrails for our entire object. It didn't really have to do much besides tracing it and piping it, right? The next thing that we might need is all the other little handrails. And this one's actually not to code, I suppose. Just because, well, you're not actually allowed to do horizontal handrails in the exterior because somebody can climb it, right? A little kid could essentially climb that and still fall over. So you may notice, especially in like newer buildings, they're all vertical now, right? Or they have a vertical and horizontal component. However, for the sake of tutorial, I'm not going to be too stickler on that. But another rule is that, well, those spaces in between those rails are 4 inches, right? That way, I don't know what babies are sticking their heads through handrails, but essentially that's where this rule comes from, is that it's small enough that a baby's head can't essentially fit through. I really wonder sometimes, like, who's doing the test? Like, are they like, you know, measuring baby heads and being like, this is what we got to do? But maybe, I mean, maybe that's the case. However, if you go to Spain, these rules do not apply in Europe, right? They have very different rules, very different stairs, and maybe less lawsuits. You can't sue like you can in the United States, but I digress. In our case, let's make some other handrails. I could do that a couple ways. I can array them. I could just simply copy them. I could offset these lines. But for the sake of just ease, let's just copy them. So I'll copy and basically take that down 4 inches. I'll hold shift to make sure that it's straight and enter, right? I could do that again over and over. And this is what I meant by just kind of the easiest way, right? Just copy it. Could take this entire piece, work smarter, not harder, and go down 8 inches, so on and so forth. As you can see where we're going with this. Another way that's kind of easy too is to do this in 3-dimensional view. Copy. Take the previous point that is the same and just copy that down. Right? And we obviously don't need that last one. We'll take the entire thing, we'll pipe it. Yep, every single one of them. I'll go a little bit smaller because that's kind of a big handrail, so we'll go with something like, I don't know, maybe a 0.25. Nice thin, like wire-esque, if you will. But my goodness, just like that. Oh, that was fun. I accidentally did it twice. But as you can see, actually, it's kind of, it brings up a funny statement. I used to have this master's professor where he had a studio called The Glitch, and basically all we did for like 16 weeks was make glitches, right? We'd literally get cameras and like skew them, and we'd do random things that were not necessarily useful in Rhino. Then we'd take a Make 2D shot of that and turn it into an abstract design of architecture. And don't get me wrong, it was a very poetic and very cool studio, but it also made me realize that you shouldn't be so afraid of mistakes. In fact, sometimes it can lead to greatness, such as Silly Putty, Velcro, Tang. You'd be surprised how many things are actually accidents that we use every day now. Tootsie Rolls is another one. Anyway, he was actually trying to make chocolate. Turns out he made like a chocolatey paste that just gets stuck in your teeth and is absolutely terribly delicious. But in our case, we're done modeling, right? We got stairs, we got rails, we got ramps, and it's only been about 30 minutes, right? And if I didn't talk so much, I could probably do this pretty quickly, especially if I was doing this for a design or a studio project. I'd want to build that elevation first. I'd want to build those sections first. And obviously in drawing those, then I could extrude them and model them as well, right? But for the sake of the assignment, we have one last part. And that one's actually not in the steps for some reason, but we do need to turn this into a plan oblique drawing. Now, you may have noticed we don't actually have that option. So if you go to set view, you can get an isometric, you can get a 2-point perspective, you can get a perspective. And to be fair, even then, 5 years ago, those weren't, isometric was like the last one to be added. But we don't have a plan oblique, right? I can't exactly get a plan oblique from this situation, right? In fact, you may have noticed it's kind of 30 and 30, right? It's an isometric, right? Like I've placed it. So the next thing that I wanted to show you guys, if we go to our Google Drive link, there is another file in here. Wait for it. If we go to Grasshopper, There's this wonderful military projection is also what a plano oblique is referred to as. So we'll go ahead and download this one. I think I already have mine loaded, but I'll download it just in case. And we'll type in grasshopper. Yes, this little grasshopper comes up. And I think I was explaining a little bit of the history with the Rhino 3D, but there used to be a Flamingo 3D, Penguin 3D, Grasshopper 3D, and they were all part of the Rhino Zoo, right? Now, since then, some programs have kind of fallen off since 1998, let's face it, and they've been compiled into Rhino itself. So if you've ever wondered why there's so many animals involved, it's because the theory behind it was like the zoo of, you know, different animals that have different traits and can do different things, very much like astrology, actually. Anyway, let's get that military projection. So actually, if you don't know how to load something, mine just kind of loads automatically, but you'll notice that it brings up a separate window. This is true of Windows or Macintosh, but you'll notice it actually has a separate Grasshopper program, so you can go to File and of course open that document. Now in my case, this comes from, you know, Jackie, which is great. And we need to input some geometry, and we essentially get an output. Now, if you read these a little bit closely, you don't have to change anything, but you know, obviously it's going to skew the angle for us, it's going to use pi, it's going to skew the x and the y by a certain degree, and so on and so forth until it actually outputs something. Now, you can almost imagine that each of these components are really just a command in Rhino, right? So it's just a really different way to visualize a set of commands. And in fact, if I know I'm going to use, you know, these commands in sequence, why not just turn it into a file? That way I can basically produce as many as I want, right? So if you're familiar with the word algorithm, this is basically an algorithm program called Grasshopper, right? So in our case, let's move this off to the side. I do want to make a separate copy just because, well, let's face it, we don't want to do all of that over again. But it is going to skew the physical model. So I don't necessarily want that, and you'll see what I mean. So I'm going to make a copy, and I'm going to rotate it 30 to 90 degrees, and I'll show you what I mean by this. Let's also not do this in rendered view while screen recording, otherwise my computer will crash. But I need to load this model into Grasshopper, right? So our input, any geometry type as an input. In our case, I helped you out. It's a BREP, because a conglomerate of solids is apparently called a BREP, and I think even that is short for another word. But we'll right-click on BREP, and we'll set multiple BREPs. In my case, you'll see that it turns from orange to a gray. This indicates that it's loaded in. And in fact, as long as you don't see any red or orange, things are going good. Now, if you do see orange, it means that wasn't just one component, right? Or maybe they weren't touching, or again, it could be a multitude of things, but you should be okay. In our case, you'll see this little red indicator, and if we hover over it, it says Draw Shaded Preview Geometry. I want to click that so I can see what the output is before I necessarily change it. And as you can see, this is the model that it's outputting. You guys see that okay? Pretty wild, right? If you ask me, that is some crazy stairs. But if we take a look at those stairs in a top view, it's a plano oblique, right? And even better, check this out. I can minimize this, and it's going to be running essentially this program. Oh, if I minimize it, I guess it actually stops. Never mind. Let's just make it a little smaller so you can see. Give me back my preview. There it is. But what's really nice about this is if I turn this model, we get some pretty instant results. Well, we'll let it load a little bit. It's got a lot to load. But it will rotate this item as well. So let's flip it maybe this side. Maybe that's a better view. And voila, right? I can't tell you how many times I've wasted on the drafting table making plano obliques when all I could do was simply use projection tools. Now, we use this view a lot in architecture, as you may have guessed, right? So if I wanted to show my professor multiple views in a plano oblique drawing and really impress them, this is definitely the tool that I would use. Now that's looking pretty good. It's a little off a little bit, so I kind of want the skewedness. Obviously, what's nice about this is now I can iterate. Now I can actually select the right view that I want. I don't just have to guess at the beginning and go, ah, man, I messed up, start over, right? It's definitely none of that anymore. But that's looking pretty good. I can imagine some good shadows coming out of that, so I definitely want to get those. The next thing I need to do is, this is just a preview, by the way, so I need to solidify it. Now, I don't know who made these programs, but if you right click and bake it, again, shows a fried egg but says bake, right? I don't know if you know anything about cooking, but that's not baking, right? Obviously that would be frying. Anyway, it is called bake, but essentially it takes that preview and turns it into a solid object for Rhino. So I'll click bake. It even goes, hey, do you want it on a certain layer? Hell yeah, because, well, I just used a bunch of layers and I actually didn't use my layers too well. I should have actually got my rails in one layer, my stairs in another layer. I definitely want to do that, right? But in our case, let's put it on stairs. All right, well, I already used stairs. We'll put it on rails for right now. Do not do that, right? But in our case, it'll immediately turn it into a model. Now, I can actually minimize that, and I no longer really need Grasshopper. Now, where it does get a little tricky is, which one am I going to use to produce my shadows?
Physical one.
I'll have to use actually the skewed one, right? Because in aligning those things, it'll be really hard. I have one that is an isometric view, but I also have one now that's in a true plane oblique. I'll have to use the plane oblique, actually. So just be careful with that. Now, it doesn't dramatically change the shadows too much, but it is one thing that now I want to use my top view and actually turn that into a render and go, oh, okay, right, I need to use this shadow, not necessarily this one, right, like the regular view. So just keep that in mind, and it's going to make it a little bit easier, and we could still change it, by the way. Now, we do have to mess with our sun settings a little bit more, and as you can see, it can get dramatic very fast because of that false skewing, but it works, right? So I'm gonna go mess around. I kind of like when the shadow kind of hits the object again. That's just me. Oh yeah, now we're talking. Oh, all right. Change the angle just a little bit. I love it. But that is actually the view that we want. We want a little bit of shade and shadow. Obviously, we want to make 2D. We want to take that render and of course put it underneath as well. We want to put it on an 11:17 in portrait. So let's go ahead and do that. We'll take this piece. I'll make 2D. Man, I can't tell you the time that I've saved. We'll make 2D. Fairly slow today. I guess it is like 100 items going on. So.
Will the make 2D like start to struggle with that or not?
Oh, it will. Yeah, the more geometry that you have or give to make 2D, or like if you do the hidden options, the tangent option, it'll definitely increase that amount of time. So if you notice your, say, laptop is struggling, guys, seriously, save it, open it up on the school computer, do make 2D. You'll notice that it's significantly better. You can take it back to your computer. Or you could even export it as a Illustrator file from there. In my case, I am also screen recording, so it does take a little bit. The hidden lines is a plus, though. I can't express that enough. You can really start to impress others. And what I mean by others is our studio professor. But there's that view that I need. And what's kind of nice is I don't really need to set the camera because the camera is just top view, right? So I don't necessarily need to save another view. But let's go ahead and render this. So I'm going to get this a little out of the way. Boop. And let's just go ahead and render that one. So we'll take our render. For the sake of tutorial today, I'll just take a screenshot. But as you guys know, in exercise 3, part 1 and 2, we definitely went over some more options that you can do there. Obviously, you can change the sun. You can change it to a spotlight if you did want those diverging rays or anything like that. But for the sake of tutorial, we're starting to really get somewhere. And I could even still change my material for these as well. So I'll take a screenshot for today. Sweet. And essentially just need to make that 11:17. So we'll go back to a shaded view. I think I already have an 11:17, so I'm going to type in show real quick. Oh, man. See what I mean by crashing when you're screen recording? Now, this is probably the best part about having a Mac, is it'll reopen. And it'll be like, I'm sorry. And there's like a little flat ball, and it's okay. I don't blame you. But make sure you press reopen if you have a Mac. If you're on Windows, I'm sorry, it's gone forever, right? It doesn't automatically create a recovery file. But in my case, it may struggle just because it did crash. Let's see what we got. We'll give it a second. But that really was about the end. So just to verbally explain it, essentially I'm just lining up that image on Rhino and using an 11:17 in portrait. Keep in mind, we do have an entire week to go over this, so if it feels very fast for you today, again, it's just for the sake of recording. But in my case, it should open that file again, and voila, we're back, right? So no big deal. Now, one thing I would say for my Windows users is definitely constantly save, right? I usually, especially when I use Windows, and especially in the office, right? Let's face it, you're getting paid by the hour to like do something, and it might be raining, thunderstorming outside. I can't tell you, this has definitely happened where I've worked for 8 hours on something that I need a deadline by today, and the power goes out. Didn't save. So it is one of those things that you do kind of want to get into a habit, especially on Windows. After every kind of major Make 2D or major finishing checkpoint, save, right? There's definitely nothing wrong with that. But just to conclude, right? And I think I was showing all my layers, that's why it collapsed on me. Let's try that again. Show. There we go. Yeah, it was trying to load all this back and it like freaked out, I guess. But in my case, I wanted that 11:17, so I'm gonna ungroup this real quick. Boop. Aw, man, it's 4 separate lines. That's okay. I can join them now with my new tools of join. So I'll copy that one. We are gonna go landscape for this one. So just to make sure we get it all, landscape. I'm gonna take my Make 2D. Oh, I guess it went back to the Make 2D. Yeah, the Make 2D probably made it crash. So I'm gonna take my hidden lines off, at least, and the tangent lines off just for the sake of tutorial. You can leave those on, let it load, because it will make a better drawing. But in my case, a little bit faster, a little less heavy. Where are we at? 10:30? Not too bad. Wait for it. And actually, while we're waiting for it to load, were there any other questions about like certain stairs that you wanted to see? Or, I mean, we did cover kind of a precast very often used in studio, which is what we did. We also showed a little bit of the floating stair, which is actually not to code, by the way. You can't do that in a commercial setting. And actually, we have a building such as the nursing building that has actually uncommercialed code. I don't know how they got away with it, but maybe 2011 was a different time. But you can actually no longer do that unless it's a residential, you know. Not that you wanted to learn anything about code today, but you did. So in our case, I'd want to take that piece. We're not doing anything to scale yet, so we're okay. And so I do want to set up my page and possibly take in my screenshot. So I'm going to type in picture. I'm going to grab that screenshot from my downloads, screenshots and recordings, and it won't let me take it in yet. Oh, there it is. Is that it? No. That's Super Mario 9.4. I don't think I got that screenshot. Okay. Maybe it crashed on the screenshot. I'm not sure. But let's get that screenshot again. Yeah. My sun settings are different as well. So let's go back to my sun. So I do need to figure that out just a little bit again. But let's say that was it. And let's say that was good. Worst shot ever. I definitely want to render this, not screenshot it. But for the sake of tutorial, let's screenshot it. And boop. Back to shaded. Now we can put in picture. And grab that picture. No, it's still not making that shot. Not sure what's going on. Maybe it doesn't want a PNG. Let's try. Downloads, screenshots and recordings. That should be it. Yeah, that's the one. But it probably doesn't want a PNG for some reason, so let's file, export, and turn it into JPEG. Test render. Sweet. Now let's try and put that in. desktop, test render, picture, picture. There we go. All right. So clearly it's something that we can actually do in Rhino too. However, when we're exporting, as you may remember from exercise 1 and 2 and 3, the picture doesn't always come into that AI file. So it is something that we usually have to do in Illustrator. So anyway, for the sake of, man, did I like nail that on the first take? Man, that's rare. That's even rare for me. But I mean, actually pretty close. Obviously, as you can see, we need to do the same thing, and I do want you to kind of get into the habit of this, right? I want you to get really fast at it. And if you notice you're kind of struggling at first, and that's like the bane of your existence right now, you're like, damn, I hate putting the image together with the lines. Is there any way to make this easier? Yeah, you can line it up in Rhino, right? Because we do have some extra tools. So for instance, I can line up one point. Dang, I really did get really close. But I could scale that image as well, which I can't do in Illustrator, at least like this. I can take a certain point, I can take the point that I need to basically align, and basically stretch that perfectly. So don't get me wrong, there's definitely some advantages of aligning that first. That way, it is gonna take the boundary for us in Illustrator, so that might be a way to line up that boundary of the image. So again, that might be useful, but at the end of the day, let's face it, the more that we make actually the tasks that we thought were hard easy, the better you start to become in these programs, the more fluent you start to become, and you don't even have to think about it sometimes. Eventually you just start kind of doing it out of habit, which is why we want to make good habits. Anyway, any other stairs that you guys want me to build? No spiral stairs, by the way. In fact, there's also a Food for Rhino program that just builds spiral stairs. And the reason I say that is because they're extremely rare now. We learned a huge lesson in the 70s that taking up a couch up a spiral stair kills people. Seriously, they fall over. I mean, it's nearly impossible. They don't meet code. People falling down them all the time. There's a reason why they've been excluded from code for so long. Now, if it's a mechanical situation like going up to a very high roof or reaching like an AC unit, don't get me wrong, there are exceptions for spiral stairs, but they're meticulously designed and often prefabricated and actually shipped to the construction site. They're not built on site anymore. Anyway, you probably didn't want to know this much about stairs, but just in case you did, now you do. So, no questions about other stairs, guys? Obviously, if we need to, I'll do a part 2, but we'll end it for today if there's no questions. Sound good? All right.